Hello YouTube, welcome back. Today I'll be going over some practice problems for composite functions. So let's get started. So question 1, it says determine the output and answer for each question, given the function f of x and the function g of x. Okay, so for part A, it's asking us f of g of 2. So the way we can immediately rewrite this is we can write this as f of, since g is in green, I'm going to use green. So you can say g of 2. That's basically the same way to write whatever's above here. So we can use these things the same way. So now that we've written it out in a different format, let's evaluate g of 2 because that's our first step. So we can say g of 2 is equal to 2 squared over 2, because I'm just using this equation over here, g of x. So g of 2 that's going to be 4 over 2. That's going to be just 2. So we figured out g of 2 is just 2. And now all we have to do is plug in 2 into our f function. So we can rewrite this as f of, let's say, 2 here. There we go. Because all we're doing is we're taking the output of g of 2 and we're just putting into the input of f. And it's interesting, the input and output for the g of 2 is just the same. So that's interesting. Let's keep going here. So f of 2, let's evaluate that. So we can say f of 2 is equal to the square root of 2 times 2. So that's going to be f of 2 is equal to, so this 2 times 2 is 4, the square root of 4 is going to be 2. So f of 2 is going to be just 2. And there we go. We have solved our equation. Now to write it in better terms, a more correct term, you can say f of g, let's just do it based off the question, f of g of 2 is equal to 2. And there we go. So essentially all we did was we took the output of g of 2, smashed that into our function f of x, and we used the input 2, and we got the output to be 2. So everything's 2 here, so it might be a little bit confusing, but hopefully you can follow along. Let's move on to part B. It asks g of f of 8. So again, I'm going to write this in planar terms. So we can say g of f of 8. There we go. That's something more readable. So there we have, given this equation here, we have to solve. So we have to first figure out f of 8. So I'm going to write f of 8 is equal to, and what is our function f of x again? It looks like it is the square root of 2 times x. So we can say it's the square root of 2 times 8 in this case. So let's evaluate this now. So f of 8 is equal to the square root of 2 times 8, which is just the square root of 16. That's going to be 4. So we know our f of 8, so we can plug this in to inside of here. So we can say g of 4, because f of 8 is just 4. So we can say g of 4. There we go. Okay, so now to evaluate g of 4, this is going to be, what is our function g of x? It is x squared over 2. So we can say g of 4 is equal to 4 squared over 2. And 4 squared is 16. 16 divided by 2 is going to be 8. So you can say g of 4 is equal to 8. There we go. And now we can write in a more standard term. We can go based off our question here. So we can say g of, g of f of 8 is equal to just 8. So interesting. We're getting this, everything's 2 over here and everything's 8 over here. So well, that's a bit of a coincidence. But anyways, let's keep moving on. So part C says evaluate f of g of x. Interesting. This isn't something we've seen before. We're sort of asked to combine the two functions generally without stating a specific value. This shouldn't be too much of a problem. All we have to do is follow our same steps, but in this case, we're going to use the entire function g of x, not just one input. So we can say f of, and we're going to just smash our entire function g of x in here. So what is g of x here? Keep forgetting. X squared over 2. So we can just rewrite this as x squared over 2. So basically all I did was is saying f of g of x, and I just plugged g of x into the function f. So hopefully that makes sense. So now all we have to do is evaluate this. So our input in this case is it's not going to be some number. It's going to be some expression. In this case, it's g of x. So we have to input that into our entire function f. So let me just double check what f is again. I don't want to mix it up. So f of x equal to 2 square root of 2 times x. Perfect. So we can just only rewrite that here. F of x is equal to the square root of 2 times x. So what we're going to do is we're going to evaluate f of x squared over 2. So let's go here. So we can say, let me rewrite this here. F of x squared over 2. That is going to be just the square root of 2 times, because we're going to replace that inside the x here. So that's just going to be 2 times x squared over 2. There we go. So it might be weird, maybe you haven't done something like this before, but instead of inputting a specific value, like a number, we're actually inputting an entire expression. And that doesn't really make a difference because all we're doing is we're just replacing it into our x value here, which I did right there. So now all we have to do is simplify. So I think what we can do is we can cancel out the 2 and 2 there. So we're just get left with, let me answer this here. So f of x squared over 2, we include the brackets here, is equal to the square roots, square root of x squared. And I think we can even cancel out the x squared here. I mean, I don't see why not. Just cancel out the radical, and we're just left with, drum roll, f of x squared over 2 is equal to just x. And there we go. I believe we've solved the question. Let's just state it in terms of the original answer. So let's go back here. So we can say f of g of x is equal to x. Now, it may seem like we are done with this question, but we're actually missing a key piece, and this is where it gets kind of tricky. So if you look at our steps, how we solve for f of g of x, you notice at this step right here, we cancel out a square root sign, and that should immediately throw off some alerts, because what we're doing is we're losing a key piece of information here. When we cancel out the square root, we don't know if we lost a positive or negative value. Like, for example, let's say at this point in the equation, we wanted to calculate the point at when x is equal to -2. Well, in this case, -2 squared is going to turn into +2, and if we take the square root of that, is -2 squared is 4, sorry, and we take the square root of that, it's going to be 2. But when we cancel out the square roots and we're left with this function down here, the point -2 is just going to be at -2 comma 2. So it's interesting, sorry, -2, -2. So it's interesting, we lost a key bit of information when we took out the square root sign here. So we're actually going to have to account for that in our final answer. So the way we do that is, because there's a square inside the square root, in this case, it's a special case, we're going to have to actually include the absolute value of x. Because whatever x is, even if it's negative, it's going to turn into a positive. And that's going to give the same number as, like, for example, a positive number. So for example, the point 1 is going to be at the points 1, and also the point -1 is going to be at the point 1 as well. So that's an important note to count for. If we just based our answer off this function here, we would be wrong. So it's important to note, if you accidentally cancel out, if you do end up, canceling out a square root, you have to keep that in mind. Okay. Let's keep going on here. So instead of, now part D asks us g of f of x. So here it asks us f of g of x. Now it's asking us the opposites. So we're going to follow through our steps, the same process that we did above. So what we're going to do is we're going to, first of all, I'm going to color code this. We can say g of f of x. F of x. There we go. And now we can just sub in our function f of x into the input of our g. So this is going to become g of, let me actually write an equal sign here. G of, what is our function f of x? It's the square root of 2x. Perfect. So we can say the square root of 2x. And that is our function f. So all we have to do is you have to plug this into our function g of x, and our input in this case is going to be the square root of 2x. So I can just write this as input this as, this will be your input. Let me just write it. This is the input into g of x. There we go. Okay, so let me just double check. I believe it's x squared over 2, but let's just double check. Yep, it is x squared over 2. So we're going to keep going here. So we're given g of, oh, whoops. Let me just rewrite this here. So g, let me just copy this here. There we go. So this is just going to be equal to, instead of x squared over 2, it's going to be the square root of this over here. So we're going to say the square root, use the square root of 2x. And this is all going to be squared all over 2. Because all we did was we replaced the x inside here. We replaced the x with the with our function f of x, and we're gonna have to square that because everything's being squared there. So that's essentially what we're doing there. So let's simplify things down now. So what we're gonna do is, I think we can actually cancel out the square root term here, so we can just cancel that out because we're squaring everything. So that becomes canceled. So we're left with, copy this. There we go. And we are left with just 2x over 2. And there we go. We can cancel out the 2 even, so we can just cancel out the 2. There we go. And we are left with g of the square root of, let me just paste that in one more time. There we go. And this is just equal to x. So we can write in more correct terms based off the question. So we can say g of f of x is equal to x. Now again, we may think we're done with this question, but we're actually missing another key piece of information. So basically, when we're solving for example, a composite function, uh, we're basically have to account for every single step. So if we just base our answer off this last step, then we might actually be wrong. Because if you look in our original process here, we see that we're solving for a g of f of x, and we notice there's a square root here, right there. There is a square root. And inside that square root, you know, inside square roots, we can't have a negative number. Like, for example, square root of -2, that's not possible. So in this step, let's say, for example, x was at -1. Well, then this entire expression right here would be it'd be a non-permissible value. It wouldn't be possible. So, sorry, not a non-permissible value. It just wouldn't be possible there. So instead of, we have to restrict our domain. So you have to actually say in our final answer, x must be where, sorry, let me do this here, where x must be greater than or equal to 0. Because whatever's inside this radical sign, it can't be negative. Yeah. So again, if you're solving for these questions, you always want to look through every single step, look for square root symbols or something like that, and you always want to make sure your x values are appropriate for that. So let's move on. Given the function f of x and g of x, evaluate f of g of 2. Okay, so our first step is to evaluate g of 2. So let's just say g of 2. And what is that equal to? So g of x is our blue function right here. So when x is equal to 2, g of 2 is equal to, let's just say this is at point. So this is 1, this is 1.5. Let's say it's at 1.4. Let's say 1.4. Okay, so it's kind of getting a bit messy. I probably should have chose a different function, but that's all right. So this is at 1, this is at 1.5. Let's just say this is at 1.4. Perfect. Okay, so g of 2 is equal to, approximately equal to, sorry, is approximately equal to 1.4. And we're asked to find f of g of 2, which now we have to plug in 1.4 into our f function, so we can say, now we have to say f of 1.4, because all we did was we're just moving that over to the inside of this function there. Use a different color. So f of 1.4, what is that going to be? So if we go to 1.4, that's going to be somewhere right there. And it looks like it is just below 1.5. So it looks like it's 1.4 again. So we can say f of 1.4 is equal to 1.4, and there we go. That's weird. We keep hitting the same numbers. Okay, so we can say f of g of 2 is equal to 1.4, and there we go.